Hey guys, it's Miss Nelson. Today your notes are going to be over order of operations, specifically pertaining to exponents and prime factorization. We're going to go over some vocab words first, and then we're going to jump right into it. So we have a base. The base is the number used as a factor. We have an exponent, and that tells us how many times the base is used. We have a factor, the number being multiplied. Prime number, a whole number that has exactly two factors, which are one in itself, and prime factorization, which is just a way to write the product of prime numbers to form a composite number. Okay, so if you look here in your example, it says 10 times 10 equals 10 to the second power. So we're going to label the pieces of these. So our two tens over here on the left are our factors. Our 10 on the 10 squared is the base, because it is what is being multiplied over and over again. And our superscript of 2 is our exponent. So now, so what we need to know, okay, about exponents, there is a specific rule that says that any number raised to the power of 0. And what I mean by that, so an example would be 3 to the 0 power, okay, make that a 0, is always going to equal 1. So that means that 1 is going to be your answer. So what this means is if I have 3 to the 0 power, that equals 1 as an answer. Okay, so that's a side note. You don't see this very often. However, you do see it at times. It's just kind of one of those things that you're expected to memorize. So anything to the 0 power is always going to get 1 as an answer. Okay, so let's look at these examples. Number 1 says create an equivalent expression for 6 times 6 times 6 times 6. So the number that keeps repeating over and over again is called the base. So in this case, our base is going to be a 6. Now, to figure out what my exponent is going to be, I count how many of them are shown. So there's 1, 2, 3, 4. So this becomes 6 to the 4th power. Number 2, express as a product of the same factor, then determine the value. Okay, so express as a product just means we are going to expand it out. So I have 1/2 to the 3rd power. So if I branch that out and expand it, that means that I have 1/2 times 1/2 times 1/2. Again, our exponent of 3 tells us there should be 3 of them being multiplied by each other, and the 1/2 is the number that is being written over and over again. So if I multiply these, I'm going to have 1 on top. 2 times 2 is 4. 4 times 2 is 8. So I get an answer of 1/8. Okay, number 3, it says use prime factorization to create an equivalent expression. Now, you have a negative 70 here. So the first thing you want to do is immediately take the negative out, and I'm going to do that. I'm going to break it down using a factorization tree, and I'm going to put the negative with the 1. So I'm going to break it out. Sorry, guys, you know it likes being crazy sometimes. Okay. So I'm going to break it out, and I'm going to have a negative 1 times 70. Now, the negative 1 is a prime number, so I'm going to break out my 70 into prime numbers, or break it down until I get all prime, excuse me. So I know that 2 times 35 is 70. I know 2 is prime. I'm going to go on to the 35. I know that 35 can go with 5 and 7. So what the purpose of this is to rewrite it as a form where it is only prime numbers being multiplied by each other. So you look at the ends of each branch. So that leaves me with a negative 1 times 2 times 5 times 7. Okay? All right, let's look at our next example, example 4 on the next page. So it says, again, use prime factorization. So I'm going to break it out. There are several ways that you can break it down. By the time we get to the end, we should all have the same prime factorization, but we may get there a different route. So some of our branches may look different whenever we are going over them. So I'm going to start with, oh, and I made a mark, didn't mean to. Okay, so I know that if I take a 10 out, I know that I have 10 and 126. So I'm going to break down that 10. I know that I have 2 and I have 5. I know in order to get 126, okay, I know that I can probably divide it by 2. So 126, and it's okay to do some side work if you need to know what your factors are. So that's going to go 6. That's going to go 3. So 2 and 63. I know 2 is prime, so I go on to my 63. I know 63 can be 9 and 7. Again, I know 7's prime, so I go to my 9, which is 3 and 3. So again, you look at the last branches of all of your tree limbs, and we're going to rewrite it, but this time, because I have the same number that shows up, I'm going to start using exponents. So I'm going to start with my lowest number. So I have 2 here, and I've got 2 of them. So I'm going to write it as 2 squared times. Now I'm going to go to my 3's. I have 2 3's. So 3 squared times, I have 1 5 and I have 1 7. Okay? And again, if I go through and I do order of operations and solve this, I should get 1,260 as an answer. Okay? So let's look at number 5. It says generate an equivalent expression using order of operations. So basically what this is saying is it wants us to answer it by doing order of operations. So now you see exponents are coming in with our order of operations. So I'm going to start, and this is when PEMDAS comes in. So I'm going to rewrite it following order of operations. So 2 times, I know 7 squared is 49, and then I'm going to rewrite the rest of it. I'm going to simplify again, and I'm going to have 2 times something. So I know that 49 minus 15 is 34. I still bring in that plus 11. In order of operations, you have to multiply before you add or subtract. That's going to get me 68 plus the 11. And now I can do that math. 68 plus 11 is going to give you a total of 79. Okay? So make sure if you have any questions, you write them down so that when we get back in class, you can ask them. Have a good day.